Here we go again. 1910.137. This is electrical. So it's a lot of slides, but it's a lot of technical stuff, which we're not going to dwell on the technical stuff because if you were involved in the manufacture of the gloves, it'd be a different story. But we're just going to talk about the use of them rather than this. So we're going to get going right now. There you go. There's your header. Just again, subpart I. We're going to cover everything in subpart I. And design requirements for specific types of electrical protective equipment. Okay, this is electrical protective equipment. Rubber insulating blankets, rubber insulating matting, rubber insulating covers, rubber insulating line hose, rubber insulating gloves, and rubber insulating sleeves. You see the common thing here? Shall meet the following requirements. All right, manufacture and marking of rubber insulating equipment. Blankets, gloves, and sleeves shall be produced by a seamless process. Each item shall be clearly marked as follows. I don't know if there can be seams in them, because obviously a seam would be a weak spot in it to let electricity through. Each seam shall be clearly marked as follows. Okay, now this is really good. I'm glad they put this in there. Class O will be marked. We mark this a double O, class O, class 1, class 2. All right. Class 3 will mark this class 3. Class 4 will be marked as class 4. And then non-ozone resistant equipment should mark type 1, and ozone resistant equipment shall be marked type 2. Okay. Other relevant markings, such as the manufacturer's identification and the size of the equipment, may also be provided. Not a bad idea. Markings shall be non-conducting and shall be applied in such a manner as not to impair the insulating qualities of the equipment. And that makes a lot of sense too, doesn't it? Markings on gloves shall be confined to the cuff portion of the glove. That's usually called the gauntlet. Electrical requirements. Equipment shall be capable of withstanding the AC proof test voltage specified in table I1 or the DC proof test voltage specified in table I2. The proof test shall reliably indicate that the equipment can withstand the voltage involved. The test voltage shall be applied continuously for 3 minutes for equipment other than matting and shall be applied continuously for 1 minute for matting. Gloves shall also be capable of separately withstanding the AC proof test voltage specified in table I6 after a 16-hour water soak. And nothing about this technical stuff is something you have to worry too much of it. And that's not going to be on any test. I'm not going to ask you that for one of those. I might ask you something on the tables, but when the AC proof test is used, the 60 hertz proof test current may not exceed the values. And again, this is the real technical stuff when you're testing the gloves. And so there's a water test, a 16-hour water soak. That's a long time being in water. Equipment has been subjected to minimum breakdown voltage. You can see a lot of this stuff's real technical, and I don't see any need to really dwell on it. Material used for type 2 insulating equipment shall be capable of withstanding an ozone test with no visible effects. The ozone test shall reliably indicate that the material will resist ozone exposure in actual use. Any visible signs of ozone deterioration of the material, such as checking, cracking, breaks, or pitting, is evidence of failure to meet the requirements for ozone-resistant material. So if you see that in these rubber insulated things, checking, cracking, breaks, or something, that could be evidence of ozone contamination. Equipment shall be free of physical irregularities that can adversely affect the insulating properties of the equipment. And that can be detected by the tests or inspections required under this section. Okay, kind of goes without saying, right? I mean, if it's going to have to work, it shouldn't have irregularities in it that will let electricity through. Surface irregularities that may be present on all rubber goods because of imperfections on forms or molds or because of inherent difficulties in the manufacturing process, and that may appear as indentations, protuberances, or embedded foreign material are accessible under the following conditions. The indentation or protuberance blends into a smooth slope when the material is stretched. Foreign material remains in place when the insulating material is folded and stretches with the insulating material surrounding it. Note to paragraph A, rubber insulating equipment meeting the following national consensus standards is deemed to be in compliance with the performance requirements in paragraph A of this section. So there you go. They're giving you some standards and then they're telling you that these other standards are, the compliance with these other standards is the same thing. And we're not going to go into all these. You see, they're mostly ASTM standards. The preceding standards also contain specifications for conducting the various tests required in paragraph A of this section. For example, the AC and DC proof test, the breakdown test, the water soak procedure, and the ozone test mentioned in this paragraph are described in detail in these ASTM standards. It's American Society of Testing and Materials. Standard Guide for Visual Inspection of Electrical Protective Rubber Products presents methods and techniques for the visual inspection of electrical protective equipment made of rubber. This guide also contains descriptions and photographs of irregularities that can be found in this equipment. Standard terminology relating to electrical protective equipment for workers includes definitions of terms related to the electrical protective equipment covered under the standard. Design requirements for other types of electrical protective equipment. The following requirements apply to the design and manufacture of electrical protective equipment that is not covered by paragraph A of this section. Voltage withstand insulating equipment used for the protection of employees should be capable of withstanding without failure the voltages that may be imposed upon it. Note to paragraph B1, these voltages include transient voltages, over voltages such as switching surges, as well as nominal line voltage. And again, that's getting into something that really are not going to get into in the field of industrial safety in the plants. So I'm not going to dwell on that. Protective equipment used for the primary insulation of employees from energized circuit parts shall be capable of passing a current test when subject to the highest nominal voltage on which equipment is to be used. Okay, good to know. When insulating equipment is tested in accordance with paragraph B2 of the section, the equipment current may not exceed 1 microampere per kilovolt of phase-to-phase applied voltage. This paragraph applies to equipment that provides primary insulation of employees from energized parts. It does not apply to equipment used for secondary insulation or equipment used for brush contact only. Again, this is something in the field you're not going to have to deal with more likely. And again, I'm not going to go into the details of this stuff here, of how this stuff is made and how this stuff is tested. I want you to know it's there. You need to look at it, but you're probably never going to use it. So I don't see you having to spend time on it. In-service care and use of electrical protective equipment. Electrical protective equipment shall be maintained in a safe, reliable condition. Now, that's part of the stuff that you need to know. I mean, it makes sense, doesn't it? Specific requirements. The following specific requirements apply to rubber insulating blankets, rubber insulating covers, rubber insulating line hose, rubber insulating gloves, and rubber insulating sleeves. Maximum use voltages shall conform to those listed in table I4. Insulating equipment shall be inspected for damage before each day's use and immediately following any incident that reasonably can be suspected of causing damage. Insulating gloves shall be given an air test along with the inspection. Note to paragraph, Standard Guide for Visual Inspection of Electrical Protective Rubber Products presents methods and techniques for the visual inspection of electrical protective equipment made of rubber. This guide also contains descriptions and photographs of irregularities that can be found in this equipment. Insulating equipment with any of the following defects may not be used: hole, tear, puncture, or cut. Ozone cutting or ozone checking, that is a series of interlacing cracks produced by ozone on rubber under mechanical stress. Well, I hope you would want to use electrical protective equipment with a hole or cut in it. And embedded for an object, any of the following texture changes: swelling, softening, hardening, or becoming sticky or inelastic. Any other defect that damages the insulating properties. Kind of a catch-all there, because I don't know how you'd know that without testing it. But let's face it, if you have protective gloves on, you're working around voltage, anything is wrong with those gloves, you don't want to use them. Insulating equipment found to have other defects that might affect its insulating properties shall be removed from service and returned for testing under paragraph so-and-so of the section. Insulating equipment shall be cleaned as needed to remove foreign substances. That makes sense. Insulating equipment shall be stored in such a location and in such a manner as to protect it from light, temperature extremes, excessive humidity, ozone, and other damaging substances and conditions. Protector gloves shall be worn over insulating gloves, except as follows. Protector gloves need not be used with Class A gloves under limited use conditions when small equipment and parts manipulation necessitate unusually high finger dexterity. Note to paragraph C2VIIA. Persons inspecting rubber insulating gloves used under these conditions need to take extra care in visually examining them. Employees using rubber insulating gloves under these conditions need to take extra care to avoid handling sharp objects. If the voltage does not exceed 250 volts AC or 375 volts DC, protective gloves need not be used with Class A gloves under limited use conditions when small equipment and parts manipulation necessitate unusually high finger dexterity. And again, persons inspecting rubber and insulating gloves used under these conditions need to take extra care in visually examining them. Employees using rubber insulating gloves under these conditions need to take extra care to avoid handling sharp objects. Any other class of gloves may be used without protective gloves under limited use conditions when small equipment and parts manipulation necessitate unusually high finger dexterity, but only if the employer can demonstrate that the possibility of physical damage to the gloves is small and if the class of glove is one class higher than required for the voltage involved. Insulating gloves that have been used without protective gloves may not be reused until they've been tested under the provisions of paragraph C2 VIII and C2IX. Electrical protective equipment shall be subjected to periodic electrical tests. Test voltages and the maximum intervals between tests shall be in accordance with table I4 and I5. Test method used under paragraphs C2 VIII and C2XI of this section shall reliably indicate whether the insulating equipment can withstand the voltages involved. Note paragraph above, standard electrical test methods considered as meeting this paragraph are given in the following national consensus standards. And there you go, more ASTM standards. Bunch of ASTM standards. Insulating equipment failing to pass inspections or electrical tests may not be used by employees except as follows. Rubber insulating line hose may be used in shorter length with a defective portion cut off. That makes sense. Rubber insulating blankets may be salvaged by severing the defective unit from the undamaged portion of the blanket. The resulting undamaged area may not be smaller than 22 inches by 22 inches for class 1, 2, 3, and 4 blankets. Rubber insulating blankets may be repaired using a compatible patch that results in physical and electrical properties equal to those of the blanket. Rubber insulating gloves and sleeves with minor physical defects, such as small cuts, tears, or punctures, may be repaired by the application of a compatible patch. Also, rubber insulating gloves and sleeves with minor surface blemishes may be repaired with a compatible liquid compound. The repaired area shall have electrical and physical properties equal to those of the surrounding material. Repairs of gloves are permitted only in the area between the wrist and the reinforced edge of the opening. So in other words, basically the gauntlet. Repaired insulating equipment shall be retested before it may be used by employees. That makes a lot of sense. The employer shall certify that equipment has been tested in accordance with the requirements of paragraph C2, a bunch of those paragraphs. The certification shall identify the equipment that passed the test and the date it was tested and shall be made available upon request to the Assistant Secretary of Occupational Safety and Health and to employees or their authorized representative. Marking equipment with and entering into logs the results of the tests and the dates of testing are two acceptable means of meeting the certification requirement. This is basically saying you have to show them to OSHA when they get there. And your employees can see what they want to. This is your proof test requirement, class of equipment. So 11-inch glove, 14-inch glove, 16-inch glove, minimum proof test current. Now, you're going to buy these gloves from somebody that's selling them to you. You're going to probably know what they're talking about, more so than they're going to find reading the standard. And you need to be sure that you see the voltages there they're going to use. So you need to buy the appropriate glove. And vendors are usually a pretty good source of information on stuff like this. And you also have manufacturers' recommendations too. There's the proof test requirement for these classes. Voltages. The DC voltages listed in this table are not appropriate for proof testing rubber insulating line hose or covers. For this equipment, DC proof tests shall use a voltage high enough to indicate that the equipment can be safely used at the voltage listed in table I4. See these two for information on proof tests for rubber insulating line hose and covers. There's your glove tests, water level. Again, these are tests on gloves that you're not going to be doing out in the field. They're going to be doing by the manufacturer, or you might have it sent out to be tested. So I'm not going to rubber insulating equipment voltage requirements, class of equipment, maximum use voltage is, say, retest voltage average, DC or AC, RMS. RMS means root mean squared. The maximum usage of the volt is the AC voltage classification of the protective equipment that designates the maximum nominal design voltage of the energized system that may be safely worked. The nominal design voltage is equal to the phase-to-phase voltage on multi-phase circuits. However, the phase-to-ground potential is considered to be the nominal design voltage if there's no multi-phase exposure in a system area and the voltage exposure is limited to the phase-to-ground potential, or the electric equipment and devices are insulated or isolated or both so that the multi-phase exposure on a grounded Y circuit is removed. The proof test voltage should be applied continuously for at least 1 minute, but no more than 3 minutes. So this is when to test intervals. Rubber insulating line hose. Look at the gloves. That's probably going to be the most common one we use before first issue and every 6 months thereafter. Upon indication of insulating value is suspect, after repair and after use without protectors. So if you buy rubber insulating gloves, you can have them on for use by your people. Mostly it's going to be your maintenance people, your electricians, obviously. They have to be tested every 6 months. When I was in California, there was a guy, I don't know how I met this guy, was at a seminar or something, and he wanted to go in business with me, and I really wasn't interested in setting up a inspection, buy a piece of equipment and setting up the inspections on rubber insulating gloves. Because in a city like Los Angeles, there's a whole bunch of them, and probably could have been all right. I don't know how people were doing it then, but that's why they're color coded sometimes. So you can get all your gloves that are color coded a certain one or through January to June, and you can have a good program to make sure they're every 6 months they're tested. So that's an important part of this whole thing. Before first issue and every 6 months thereafter, rubber insulating gloves, or upon the indication of installation of suspect, and after repair and after use without protectors. That's when you have to test them. That's the big takeaway actually from this whole chapter. And that's it. You can see most of that is stuff it's a long standard. Most of it's real technical stuff that you're not going to use, but do know that 6 month thing. That's one thing that I hold you to out of this whole standard that have to be tested every 6 months. So anyhow, if you're using rubber gloves, they got to be in good shape too. So, all right, that's it for now. Be safe.